Supplemental math videos from Circle Christian School. The quadratic formula. It's all about singing the song. It's nothing but a formula. Algebra loves formulas. Plug things in and work with the real numbers. It's the best kind of math. X equals negative b plus or minus square root of b squared minus 4ac all over 2a all over 2a. Learn this song will save your life, at least your math life. Before we use the quadratic formula, let's talk a little bit about quadratics. They cut the same shape. The parent function, y equals x squared, this is where x is squared, makes either a positive parabola, that's what I kind of call my smiley face, or a negative x squared, or a negative parabola, the frowny face. In real life, it's pretty much what happens when you bounce a basketball, it makes a curve, or if you throw a football, it makes a curve because eventually gravity pulls it back down. Binomial form, x plus a times x plus b, binomial times binomial equals 0. It makes them FOIL it out, do that super distributing thing, and we'd have the FOIL part where we have an x squared and some x's that need combining in the middle. General form is ax squared plus bx plus c equals 0, where a, b, and c are real numbers. Again, this makes a parabola, it's quadratic. And then there's kind of this other sneaky little form that we call vertex form, which is called standard form. Y equals a times x minus h squared plus k. The h and the k tells you where the parabola is hanging out. It's the vertex. And the a out front tells you if you have a skinny parabola or a wide parabola. It's kind of like the slope, a rate of change that's happening here. It's just that it is somewhat exponential in how it moves. The whole reason why we factor a standard quadratic equation is so that we can bring it back to its binomials. We factor to go find x. This is known as the zero product rule, or basically everything equals 0. So if we were to have a binomial times a binomial like x plus 4 times x minus 3, the first factor here we would set to 0. X plus 4 equals 0, so therefore x would equal a negative 4. Throw it back inside here to give it a try. We would have 0 times negative 7, which still equals 0. Likewise, on the x minus 3, we let it equal 0, and we find that x equals a positive 3. Throw it back inside the original equation, we would get 7 times 0 again, and yes, it does make a true statement of equaling 0. We factor to go find x. That's so we can set x to 0, not x squared to a 0 or x to the third power to the 0. X equals 0. So, just to take our little binomials, change the form, practice a little bit of foiling here. I call it super distributing. I'm going to take the first one here inside the first binomial, the x. I do little arrows. It all means FOIL also. I just kind of like a circle arrow person instead. And we have x times x. Talk to yourselves as you do it. It will kind of help you from being confused. X times x. That gives us x. Next, we have x times the negative 3, which would give us negative 3x. I circle the second part because that's what I'm going to distribute to everybody in the second binomial here. Positive 4 gives me a positive 4x. And a positive 4 times a gives me a negative 12. And of course, this still all equals 0. Now this is what I called FOIL form, because we have the guys in the middle that we still have to combine. And our final quadratic would be x squared plus x. And if you want, you can put a 1 there. There's nothing wrong with that. Negative 12 equals 0. Equation as a binomial is the same equation as the quadratic form. They just have different faces to them. They still make a parabola with the same vertex hanging around in a coordinate plane, where it crosses the x-axis at a negative 4 and a positive 3. I'm going to take 3 examples here and just show you some differences in being able to go find x. First one, we're going to factor, of course, to go find x. That's why we factor. But this particular quadratic equation, you'll notice that the a here equals 1. This is what I call the nice double bubble, because you know automatically that this up front is going to be an x and an x. That's what gave us the x squared. And then what we have to do is look at the 10 here and go, gee, factors for 10 that when we add them together equals 7. Well, let's see, 2 and 5 when multiplied equal 10, but when we add them both together, they equal 7. Oh, okay, so if we FOILed this out, we would get x squared plus 7x plus the 10. And if we set each one of these factors, these binomials, to 0, x plus 2, we know x would equal a negative 2. It's just an opposite sign. And x plus 5 set to 0 would equal a negative 5. Sometimes we have to factor by grouping, or what I call F by G. Some teachers and some models will teach this to you as a trial and error double bubble. I have never, ever been good at that. I just noticed I had a 0 sitting down here and I don't want it, so let me white it out before I get there. Woo! Okay, very good. So what I'm going to do is, this is when we have a quadratic equation where the a sitting up front here does not equal 1. So we're going to have to do a little bit of work. But what I do is I just walk backwards to my binomials. Factor by grouping allows me to see the FOILed form. And I can make little groups. The associative property says I can make groups. And I factor out of the groups. That gives me my binomials. So to do that, what you have to do is take the a, which here is 2, and the c, which is a negative 3, and you have to multiply those together. So you need factors for a negative 6 that when you add them together equal the middle number, the negative 5. Okay, well, let's see. Factors for a negative 6. Well, we have 1 and 6. And I'm going to write that twice because the 1 could be a negative or the 6 could be a negative. And we have a 2 and a 3 and a 2 and a 3, and the 2 can be negative and the 3 could be negative. And I'm going to see which pair of factors here add together, give me a negative 5. Now you'll be real tempted to work with these 2's and 3's, but notice they both don't have a negative, so we can just totally disregard those. And with the negative 1 and the 6, I add those together, That gives me a positive 5. So I'm going to have to use the 1 and the negative 6. So I'm going to break it into the FOIL form, take my middle number here and break it apart to be a positive 1x and a negative 6x. Those together, you add them together, like terms, would give us the negative 5x. And I'm going to bring down everybody else. So here's my 2x squared and my negative 3. All right. This is the FOILed form. This is what you get if you took the two binomials and FOILed them together. And I'm going to put groups around my first part, leave the sign in the middle, and a group around my second part. And now I'm going to factor by the groups. I'm going to factor out a common factor inside the blue parentheses. So I have 2x2 and 1x. First I do numbers. Nothing really common between the 2 and 1. And then I have an x squared and an x. And the common factor there is an x. And that's going to leave us with a 2x plus 1. All right, now we're just going to bring the sign down. 6x, negative 3. I can take a 3 out of both of those. Divide a 3 out. And that will give me a 2x plus a 1. Now notice that the numbers inside, or the terms inside the parentheses, are exactly the same. If you don't get twins on the parentheses here when you're factoring by the groups, then you did something wrong. They have to be twins. So the first binomial and my second binomial is going to be what we factored out, the leftover, the x minus the 3. And now I have my two binomials that I can set to 0 to go find x. The first one's going to be opposite sign over the first number, and of course the opposite sign of the guy in back there. If we were to plug it back in to the quadratic equation, we would get 0. Now my default method for solving is to use the quadratic formula. The negative b plus or minus square root of b squared minus 4ac all over 2a all over 2a. Where what you have to do is identify your a, your b, your c, make a template, and plug everybody in. Next screen. All right, let's try two of these. The first one, you'll notice, take on exactly that quadratic form, but we do know it's quadratic because the x squared is here. Anytime you got an x to the second power, it's a parabola. You can use the quadratic formula. It's just that we have to set everything to 0. So I get an x squared plus a 7x. We're going to take away 10 from both sides, or what I like to say, if anybody has to jump the fence here over the equal sign, then we just change the sign. So a equals 1, b equals a positive 7, and c equals a negative 10. Real numbers, real math, gonna plug it in. Okay, so I do all my a's. And then I'm going to do my b's. And then we do the c's. All right, real numbers, real math. Going to do the first one right up front here. And I bring it down a little bit. See if I need to simplify any fraction work. We get a negative 7 over 2. Do not have to simplify the fraction. Now just go ahead and put my little plus minus here. Now we're going to work on the second part. All right, 7 squared is a 49. Signs first, math second. I have a negative negative, so I know it's going to be a positive. 4 times 1 times 10 is 40. And we get a square root of 89 over the 2. Not exactly what I planned, so I'm going to have to think about this. Oh, I see what happened. That's fine. I don't have a problem with that. Okay, so 89. Now, I happen to know that 89 is a prime number here, so I do not have to do any simplifying of the radical. And I'm going to put it over 2. And there's your answer. Now you can actually take your calculator and give it a measurement value. Some answers in the back of the book will be one way and some will be another way. And then we would do the minus value. And with your handy dandy little calculator, and on the first one we would get approximately 217, and on the second one we get approximately negative 8.217. Or you can leave it as the radical type form. Just kind of depends on what somebody wants at any given time. All right, let's take a look at the next one. Identify your A, your B, your C. It's already set to 0, so that's okay. So A is going to be a 2. B is going to be a negative 3. Watch those signs. And C is going to be a negative 10. And I'm going to plug everybody in. Plug in the A's. After you do about 10 of these, you kind of start to remember the formula. Negative 3, see how the parentheses keep the negatives happy. And C and negative. Okay, going to do the work. Going to bring this a little further down because I think I might have a little more work going on this one. Negative, negative, positive, 3 over the 4. Okay. 3 over 4. That's the first part. Now I'm going to work with the radical part, which we see is going to give us a 9. It's going to be plus 8 and 10. Oh my goodness. Going to be awfully darn close to the last answer, except for the others had 2s and these had 4s. This is square root 89 over the 4. And remembering that the square root 89 is prime here, so we don't have to do any simplifying. And there we go. We have quad formula our way through the quadratic equation. Default method works pretty good for all of them.